Also, I explained you like how will you will be assessed, what will be the internal marks, and all those other things. I just explained you people, and I also told you which kind of textbooks you have to refer, and what kind of textbooks I am referring, and what you need to do to understand this subject very clearly. I uh, told that in my last class also, and this class also I'm telling you, like please concentrate more on the conceptual part rather than on solving more and more numerical examples, because solving more and more numerical examples will not make you perfect, right? But understanding the concept clearly will make you perfect in any type of numerical example given to you. Like if it is also twisted, then also you will not have any difficulty if you have understood the concepts very clearly. Okay, so let me start with my first thing. What I am going to do is I am going to start with my first module. But first module contains two parts. The first part deals with the theoretical things like elements of civil engineering. So you will be exposed to what are the different branches of civil engineering and how they are actually interconnected with each other. Then you will be told about what is the role of a civil engineer in the infrastructural development of a country, and many other things are there which are on the elements of civil engineering. Okay, that is a totally theoretical part. No numerical examples are there involved in that. So what I'm going to do is to bring more interest from your side on this subject. So rather than starting with the theoretical part, that boring stuff and all those things, so we'll not concentrate at this point of time on the theoretical part. Instead, I'm going to start with the second part of my first module. The second part actually deals with the engineering mechanics, right? The second part of the first module deals with engineering mechanics. So I'm going to start with the subject on engineering mechanics. Okay, so now what do you mean by engineering mechanics? So instead of understanding that part initially, first let us concentrate on what is the meaning of mechanics, right? So then we will understand what is engineering mechanics and what are the different branches of engineering mechanics and all those things. First let us understand what you mean by mechanics. Now mechanics is a branch of physical sciences. So I request everyone, no need to take down any notes, okay? Just listen, and if you want to write down any important points, you can just note down the important points. No need to write any of the notes. I'm not going to dictate any notes, okay? Dictating notes and you people taking the notes and all those things, please leave that all in your 10th standard PUC 1 and 2, okay? No need to take any notes. I'll be giving my handwritten notes to you on the class WhatsApp group. You can study during the exam time, but at this point of time, if you want to remember something, you can just note down some important points, right? Because if you start taking down the notes, you may miss some of the important concepts, so don't do that. Okay, now I will just explain you what do you mean by the mechanics. Mechanics is actually a branch of physical sciences. Okay, it is actually a branch of physical sciences that is concerned with the state of the rest or motion of a body that is subjected to action of forces. Let me repeat once again. Mechanics is the branch of physical sciences that is concerned with the state of the rest or motion of the body that is subjected to action of forces. Now, what actually means? Now, mechanics means if you consider a body, suppose say any it could be any body, right? It the mechanics is a branch of physical sciences which deals with the state of the rest or motion. This body could be at the state of rest or it could be moving also, right? So it actually deals with the state of the rest or motion of the body that is actually subjected to force. When the body will actually move, when you apply some force, okay, then only it will move. So that thing of study of a body, if it is at the rest or if it is at the motion, so that kind of branch is actually studied under the mechanics part. Okay, now mechanics has some three major branches which are there. Mechanics is comprised of three more important branches. Now what are they? The first branch and very common branch is rigid body mechanics. Is actually rigid body mechanics. Okay, and the second one deals with deformable body mechanics. I'll explain you each one of them one by one. The second branch deals with deformable body mechanics, and the third one deals with fluid mechanics. Okay, now what do you mean by rigid body mechanics, or what do you mean by the deformable body mechanics, and what do you mean by fluid mechanics? Let me explain them one by one. But before that, let us understand that, so out of these three branches of mechanics, we are going to study only rigid body mechanics in this semester. Means in this subject, that is elements of civil engineering and mechanics, we will be studying only this rigid body mechanics. Deformable body mechanics and fluid mechanics we are not going to study, but because that comes for the higher semesters. But deformable body mechanics and fluid mechanics, they are actually taught for the civil engineering student, maybe in the semester third and fifth. Okay, so not in the first semester, but for you, the subject only deals with only the rigid body mechanics and not deformable body or fluid mechanics. But we can understand what you mean by deformable body mechanics and fluid mechanics in the later stage. But to study deformable body mechanics or to study the fluid mechanics, this rigid body mechanics study makes a foundation. Means this makes a prerequisite to study deformable body mechanics and the fluid mechanics. Now further, the rigid body mechanics is actually divided into two more important parts. Further, the rigid body mechanics is divided into two more important parts, and they are, the first one is statics. Okay, don't confuse with the statistics and statics. Statistics is a different one and statics is a different one. And the second part is dynamics. Okay, and the second part is the dynamics. So we will be studying both statics and the dynamics in this semester. Now the fifth module actually deals with the statics part for your subject, the fifth module, and rest all the modules actually deals with the statics part. Now what do you mean by statics and what do you mean by dynamics? Let me explain you that. Now the statics actually deals with the equilibrium of bodies. This actually deals with the equilibrium of bodies. Students, have you heard about the term equilibrium?
Yes, sir.
Yes.
Yes, sir.
Yeah. Can anyone just give me a rough idea about what do you mean by equilibrium? Anyone? Okay, instead of yeah, just a minute, just a minute. So if I ask you anyone, it could be a problematic. So I have a list of students, so I can call by name. Mm, let me ask. Okay, Harshita M, are you there? Harshita. Okay, Swapnadeep. Okay, you can.
Motion of a body.
Motion of a body. Yeah, next what? That's it. Motion of a body. That means equilibrium.
Yes, sir. I think. Yes, sir.
Okay, anyone? If you want to, yeah, Pratiksha.
Sir, it's the state of a body where everything is stable.
Yes.
Mm, not so perfect answer. Partially correct answer. Anyone?
Sir,
Sir,
influences are cancelled by each other and it remains stable. That state is called equilibrium state.
Stable, you mean to say, is it, will it be at the rest or will it be in the motion?
It will
Rest,
be
sir.
in motion.
not at rest.
Forces and
Not at rest.
actions
Sir,
Will
are
it
not
is
be in
in
rest,
motion,
it
sir.
will be in
Just
motion.
just
Opposing
just
force,
just a
sir.
minute. Just a minute. Just a minute,
forces
students.
and actions are balanced.
Forces and
Forces
actions are
forces
balanced. Okay,
yes sir.
almost 90% is correct.
Equal actions of opposing forces, sir.
Okay, so if I just want
The
to,
condition of system, sir.
yeah, it is a
Neither its state or motion or its internal energy.
uh, oh no, that
Single particle.
Sir, it
yeah,
is a state of rest due to opposing forces.
state of rest or motion.
It is equal is zero,
Where
sir.
A state of balance, sir.
Force acting upon the particle is zero,
due
sir.
to
Okay. Please mute. Please mute. Let me just tell you in a single sentence. Most of you are actually to the point, but not gave you exactly answer. Some people said it is the state of rest, not motion. Some people said it is the state of motion and not the rest. No, it is not like that. It is actually the bodies. Those are either at the rest or move with the constant velocity. Okay, it is the state of the body if it is at the rest or if it is moving with some constant velocity. Okay, so I didn't said only moving. Okay, only moving may involve some acceleration also, right? So it may have some acceleration. So acceleration, if it is changing, so then also we can't call that body as a in a equilibrium. Either it could be at the rest or it should be in a motion with the constant velocity. So that term constant velocity is very, very important if you want to define the equilibrium. So is it clear, students, now?
Yes, sir.
Yeah. Okay. So
Yes,
Yes,
sir.
sir.
yeah, you should be very clear in your mind what is the meaning of equilibrium. Equilibrium means the bodies which are either at rest or if the bodies are having some motion with the constant velocity. So when you deal with such kind of bodies, either which are at rest or which are moving at a constant velocity, so that kind of steady is actually called as the statics. So that is actually called as the statics, right? Now how can you define dynamics? Now how can you define dynamics?
Scientific study which involves the movement.
Okay.
Spontaneous movement of a body.
Spontaneous movement of a body. Just now explained statics. Just the opposite of statics is dynamics. So can you just define in that term?
state of body if it is at ununiform motion, non-uniform motion.
Okay, yeah, correct. It is almost correct. So dynamics is the branch wherein you study or which deals with the body which is having accelerated motion. Okay, in the statics I told the constant velocity, and in dynamics you study the body when it is having some accelerated motion. Okay, it means the velocity is not actually constant. So let me just write down that one part here. So it deals with the body, it deals with the body
Mechanics.
with the accelerated motion. So are you clear, students, now? The
Sir, actually,
different,
the motions it will be told us.
yeah, pardon? Okay, right. So please mute and let me just continue that. So is it clear, students, the difference between statics and dynamics?
Yes, sir.
Yes.
Yeah, okay.
Yes,
Yes,
sir.
sir.
So in our subject, we are mainly studying engineering mechanics. So if I want to summarize, so whatever I had told right now, till now, so we will be studying the engineering mechanics subject. So in the engineering mechanics, we have three broad branches. So the first deals with the rigid body mechanics. The second deals with the deformable body mechanics. And the third one deals with the fluid mechanics. Now, Just a minute, students. Yeah. So the engineering mechanics we are going to study. So in the engineering mechanics, so the mechanics is a branch of science which deals with the state of rest or motion of the body. So in engineering mechanics, we have three more main branches: the rigid body mechanics, deformable body mechanics, and the fluid mechanics. We will be studying only about the rigid body mechanics in this subject, that is in this course. And the rigid body mechanics has two more parts, that is the statics and the dynamics. So the statics is the one which deals with the equilibrium of bodies. Okay, either it could be the equilibrium of bodies, I mean to say whether the bodies could be either at the rest or they could be moving with the constant velocity. Now the dynamic deals with the bodies which are having some accelerated motion. So we will be studying both statics and dynamics in this course. Dynamics comes only in the fifth module. That is where we are actually learning the kinetics or the kinematics part. So that part we'll see it later, but we will concentrate more on the statics part. Okay. Now, after studying or after knowing about the some of the things related to mechanics, now let me move on and just see some of the fundamental concepts which are very much important. I think these fundamental concepts you have already learned, so I will not waste my time much more on this fundamental concepts, which are actually important for the study of mechanics, right? Now, it is always better to understand a few of the fundamental definitions and concepts before proceeding with the study of mechanics. So, I will just brief about some of the basic quantities which are very much important to proceed further. So, the first basic quantity which I'm going to tell you is the length. So, there are two more things are there. So, can anybody tell me what are the other two things?
Breadth and height, sir.
No.
Temperature, pressure, sir.
No.
Mass.
Yeah,
Mass.
one of them is mass,
Mass.
and other one.
Time,
Yes.
sir.
Yes, perfect. Okay.
Time.
Yeah. The after length we can see about time, and after time we can see about mass.
Mass.
Okay, so these are the very important things. I think LMT, if you need to remember that, so it is LMT. Let me just go through what do you mean by length. Length is used to locate the position of a point in space, okay, and thereby describe the size of the physical system. So the length is the one which is required to locate the position of point in space and thereby describes its size of a physical system. Once a standard unit of length is defined, okay, it could be meter, centimeter, millimeter, or whatever, kilometer or whatever. Once the standard unit of a length is defined, one can use it to define the distance and geometrical properties of a body as a multiple unit of that. For example, if I want to say, if I want to just give you some idea, this is a cube, okay?
Cube.
This is a cube. Now, once you know, once you are able to define the uh, unit of a length, okay, unit of a length, like say if I able to define the unit of length as say meters, now then you can easily define the geometrical properties of this cube. So one of the geometrical property could be, can anybody, any one of the geometrical property of this cube, anyone?
They have same sets.
Huh?
Same sets.
No. Any one geometrical
Length, sir.
property.
Length, sir.
Length you have already defined.
Breadth and height.
Breadth and height is also a length. Means it is defined in terms of length. Yeah, correct. It is. Yes.
Volume.
Volume. What could be the other?
Area.
Yes, area.
Area.
Yes. Okay. So
Area.
yes. Okay. Please.
Perimeter.
Yeah. Okay, please. Okay, done. Please mute. Okay, so one of them could be volume and the other one could be length. So I can define volume in terms of meter cube, which is actually a multiple of length, and I can define area in terms of meter square. That is also a multiple of length, right? So once you define the proper unit of a length, the geometrical properties of a body can be expressed in terms of multiples of this unit. Now coming to time, time is conceived as a succession of events, although the principle of statics are time what? Dependent or independent? Can anybody? I will repeat once again. Wait. Principles of statics are time dash what? Dependent or independent?
Independent.
Yes.
Independent.
Yes.
Independent, sir.
Independent. Okay. Now the dynamics is a dependent or independent?
Dependent.
Yes. It is dependent. Correct. It is dependent because in dynamics we say about velocity, acceleration, and all those things which are mostly time dependent. Not mostly, they are actually time dependent. But in statics, we don't see any term which deals with or which connects with the time parameter. So statics is a one where in it is independent of time, right? But the dynamics is the one where it is dependent on time. But this plays a very important role in the study of dynamics, as I told. Okay. Now coming to mass. Mass is a measure of quantity of matter that is used to compare the action of one body with that of the other. Okay. So this property manifests itself as a gravitational attraction between two bodies, right? Gravitational attraction between two bodies. Please mute. Gravitational attraction between two bodies and provide a measure of resistance of matter to change in velocity. So it is very little bit confusing to say. I imagine it is a measure of quantity of a matter. Okay, you can imagine like that. It is a measure of quantity of matter that is used to compare the action of one body with the another. Means, for example, if this is your Earth surface, and if you're throwing some ball on the top, okay, so it is actually the mass which defines the attraction between this ball and the surface of Earth, so that you can imagine something like that, mass. Right. Now coming to the next basic quantity, which is very much important and which we will be seeing more often, is a force. Okay, force is another fundamental concept which will be involving in our statics discussions. Now, in general, force is considered as a push or pull. Okay, force is considered as a push or pull exerted by one body on the another. It could be something like this. A body is there. Either you can push the body or you can pull the body. Okay, so this force deals with the push or pull exerted on by one body and the other body. So, and there could be another body, or it could be you only which who are pushing one body, or you are actually pulling one body. So that kind of push or pull exerted by one body on another body is actually termed as a force. Now this interaction can occur when there is a direct contact between the two bodies. Of course, this interaction can occur when there is a direct contact between the bodies, such as a person pulling a wall, or it can occur through a distance when the bodies are physically separated. Now I want to ask you one question here. I told that the interaction can occur when there is a direct contact between the bodies, such as a person pulling a wall, or it can occur through a distance when the bodies are physically separated. So can anybody give me an example for the second one, when there is no physical contact but the bodies are
Gravitational force, sir.
yes, perfect. The
Magnetic force.
Yes.
Magnetic force.
Another one.
Magnetic force. Magnetic.
Which could be the another one?
Electromagnetic.
Electromagnetic or electric, magnetic, gravitational. Many are there, which are also a kind of force, but the bodies are not in contact with each other, so still they are exerting force on each other. So that kind of thing is actually also called as a force. Or force could be a contact between the two bodies, or like if you want to push a wall, or if you want to pull a car, so that kind of thing is also called as a force, right? Now in any case, force is actually characterized by three things, right? So I want to just explain you this concept clearly here. Force is actually characterized by three things. Suppose, for example, let us say this is the body. The first characteristic is the magnitude. That is, let us say F, okay? Means how much magnitude of force, like how much kg or how much kilonewton or something like that. First thing is the magnitude. This is very important to understand. First one is the magnitude of the force. And the second one is the direction of force. The second one is the direction of force. And the third one is point of application. And the third one is point of application. Suppose say I am trying to apply a force on this body. Now this force has a magnitude, say F, okay? And I also need to define its direction, whether it is from left to right, or it is from right to left, or whether it is from up to down or down to up, something like that. So I have to also define the magnitude. I have defined the direction. Also, I need to define the point of application of this force. So a force is always characterized by these three parameters, that is magnitude, direction, and point of application. So is it clear, students?
Yes,
Yes,
sir.
sir.
Till now,
Yes,
whatever
sir.
we have discussed,
Yes, sir.
I hope the things are clear.
Yes, sir.
So any doubt you have, please ask me. Okay,
No,
right.
sir.
So let me proceed next. Now, a force is a vector or a scalar?
Vector.
Vector, sir.
Vector,
Sir.
sir. Vector.
Yes,
Vector.
yes.
sir.
It is a standard thing. So force is a vector
Vector.
thing, okay, not a scalar, because it has both magnitude and
Magnitude and direction.
direction. Okay.
Direction.
Now, regarding force, the common symbol, if to represent a force, is actually given by F. Okay, we usually give the common symbol for the force as capital F, not small f also. Okay, we usually give it by the capital F. Now, what is the SI unit of force?
Newton,
sir.
Yes,
Newton, sir.
Newton.
Newton, sir.
Okay. Now, do you write Newtons the symbol small n or capital N?
Small n.
Then, sir.
Capital N, sir. Capital N.
Capital N.
Yes,
Capital N.
it is always capital N. Okay, don't write small n. Now, if I represent kilonewton, how will you write? K small or capital?
Capital, sir.
No, 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 no,
Small,
no,
K,
no.
small, sir,
Small,
small, sir.
N.
Always-
Small, sir.
When you write
Small
kilonewton,
capital N.
K should be always small and N should be always capital. Okay. Now the base SI unit for Newton is actually defined as kg meter per second square. Okay, this is the base SI unit of force. Okay. Now, what are the dimension of a force in terms of LMT? What are the dimensions of force in terms of LMT?
M1, L1, T minus
T minus 2.
I can say
minus
something
two.
like this.
And
For mass,
ML T minus 2.
for
ML T
mass,
minus 2.
sorry, it is not like that.
ML T minus 2.
So it is L, I can
M,
say
L,
L
minus two.
M T minus.
T minus.
Okay, because why L is for the length, that is mass, that is meters.
Mass
Okay,
meter.
and M
Meters.
is for kg, and divided by second square it is. That's why T raised to minus 2.
Reciprocal.
Okay. Now, what are the effects of force on a body? What could be the effects of force on a body? So I will just list it down. So it is a very common thing. Logical answer can be given by anyone. Uh, Effects of force on a body are: force can make resting body to move. Of course, if the body is resting and if you apply the force on the body, it could make the body to move. It can stop a moving body or slow it down. Okay, so please mute. Okay, if the body is having some motion, okay, if you apply the force on the body, maybe in the opposite direction or maybe in the same direction, so it could either make the body to rest, or it could make the body to slow down, or it could make the body to move with the more acceleration, right? It can accelerate the speed of a body, so that I told already. It can also change the direction of a moving body along with its shape and size. If you apply a force on a body, also it can have the effect of change of its direction along with its shape and size. Is that clear, students?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Right. Okay. Now let me just stop here and let us just once again summarize whatever we have learned till now. These are all the basic things we have already learned, but maybe I thought it will be injustice if I just don't tell all these things, uh, conceiving that you have already learned that, but I should have told all these things, but so I have told. So we'll once again just brush up whatever we have learned. So we are going to start with our engineering mechanics study. So the mechanics is the branch which deals with uh, the physical sciences that is concerned with the state of the rest or motion of the body that is subjected to some action of forces, right? So the mechanics has three more important branches. The first one deals with the rigid body mechanics, second one deals with the deformable body mechanics, and the third one actually deals with the fluid mechanics. So in our course, we will be learning only about the rigid body mechanics and not the deformable body or fluid mechanics, because that are actually taught for the higher semester in civil engineering and mechanical engineering. But to study deformable body mechanics and to study the fluid mechanics, the rigid body mechanics study is very, very important, because that makes the base. Now, rigid body mechanics has two more important things, like statics and dynamics. The statics deals with the equilibrium of bodies. Equilibrium, I mean to say, which are having either the state of rest or the state of motion with the constant velocity. Now, the dynamics deals with the body which are having accelerated motion. Right now, we also started to see about some of the fundamental concepts. So in that, we are supposed to see the basic quantities. The basic quantities are length, time, and mass. Okay, I have told what do you mean by length, time, and mass, and I told that statics is the one which is independent of time, and the dynamics is the one which is dependent on time. Okay, then we started with our discussion on force, and we have explained you what do you mean by force. Force is actually push or pull exerted on the body, and there could be two types of forces which can be generated, where either the force can be generated when the two bodies are in contact with each other, like you are pushing a wall or you are pushing a car, something like that. Also, the force can occur when the bodies are separated, which are not in contact with each other. So that comes under the gravitational force, magnetic force, electromagnetic or electric force, something like that, right? And I also told you, to define a force, you should have three characteristics defined for a force. The first characteristic is a magnitude, like you have to express the magnitude of the force, whether it is a 10 kilonewton, 5 kilonewton, 20 kilonewton, 100 kilonewton, 1000 kilonewton, something like that. And also you need to mention the direction of the force, whether it is from left to right, right to left, up or down, something like that. Also, you need to mention the point of application of the force, means where the force is being applied. So that also you need to mention. So three parameter constitute the characteristic of a force. And we know that force is a vector quantity, and its symbol is capital F, and the SI unit is newtons, capital N symbol, and the base SI unit is kg meter per second square, and its dimensions are LM T raised to minus 2. right? So these are the things which we have learned till now. So in my next class, what we'll be doing is we'll be actually learning about the basic idealizations which are need to be made to study the engineering mechanics subject. The basic idealizations are like particle, rigid body, and concentrated force. Then we will see slowly Newton's laws of motion, that is the first law, second law, third law. Another law is there. Can anybody tell me what is that? What was that? Newton's. Apart from these three laws, there is another law.
Gravitational law.
Yeah, Newton's law of gravitational acceleration, we call it. Okay. We will learn all these things and then we will slowly come to the force part. Okay. So I will tell you some of the principles which are used in the force. So slowly we will go. Nothing to worry. So at any point of time, any doubt is there, please ask me. Are you clear, students?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Right.
Sir. So can I ask question?
Yes. Yes.
So